Let's now take some limits involving composite functions. So over here we have the limit of g of h of x as x approaches 3. And like always, I encourage you to pause the video and see if you can figure this out on your own. Well, we can leverage our limit properties. We know that this is going to be the same thing as the limit. Actually, let me write it this way. This is going to be the same thing as g of the limit as x approaches 3 of h of x. Or I could say the limit of h of x as x approaches 3. And so we just need to figure out what the limit of h of x is as x approaches 3. So let's look at h of x right over here. And as x approaches 3, so we see that h of 3 is undefined, but we can think about what the limit of h of x is as x approaches 3. As x approaches 3 from the left, we see that the function just stays at a constant 2. So at h of 2.5 is 2, h of 2.9 is 2, h of 2.999999999 is 2. So it looks like when we approach from the left, the limit is 2. And we approach from the right, we get the same thing. H of 3.01 is 2, h of 3.001 is 2, h of 3.0000001 is 2. So this limit right over here is 2. So this is all simplified to g of 2. Now what is g of 2? Well, let's see. This function here, when x is 2, g of 2 is 0. So this right over there is going to be 0. And we're done. Let's do a few more of these. All right. So we want to find the limit as x approaches -1 of h of g of x. Well, just like we just did, this is going to be the same thing. This is equal to h of the limit as x approaches -1 of g of x. So let's try to figure out the limit of g of x as x approaches -1. So this is the graph y equals g of x. And we see at -1 right over here, we have this discontinuity. And as we approach x equals -1 from the left, it looks like we go unbounded in the negative direction. So you could say we're approaching negative infinity. And as we go from the right, looks like we are, as we get closer to x equals -1 on the right-hand side, looks like we're approaching infinity. So even if they were both approaching the same direction of infinity, we would say that the limit's not defined, or at least that's the technical idea here. But this is one's going towards positive infinity, and the other is going to negative infinity. So this limit right here is undefined. So it doesn't exist, or I should say, does not exist. So if the limit as x approaches -1 of g of x does not exist, well, there's no way that we can evaluate this expression. We can't find h of does not exist. So this entire limit does not exist. Let's do one more of these. All right. So we have, once again, limit of h of f of x as x approaches -3. This is the same thing. This is equal to h of the limit as x approaches -3 of f of x. So let's look at f of x. This is the graph y equals f of x. And the limit is x approaches -3. Well, as we approach -3 from the left-hand side, as we get closer and closer to -3, it looks like we are approaching the value of 1. And as we approach from the right-hand side, it looks like we are approaching the value of 1. If I were to take from the left-hand side, if I were to take -3.1, -3.01, -3.001, I'm going to get closer and closer to, if I evaluate the function there, so I should say f of -3.1, f of -3.01, f of -3.0001, we're getting closer and closer to 1. And same thing on the right-hand side. So this thing looks like it's 1. So now we just have to evaluate, and I'll rewrite it. So this is the same thing as h of 1. h of 1, so we just have to evaluate this. But then when we look at this graph here at 1, this function does not look defined. So h of 1 is actually undefined. Undefined right here. So also in this case, this limit would not exist. Once again, the limit part was actually, at least the limit of f of x was fairly straightforward. But then when we tried to take that output and put it as the input into h of x, well, h of x, h wasn't defined there.